This video is brought to you by MathGalaxy.com, and it's the third and last of our sessions on SAT arithmetic number properties. And we'll be looking at properties of zero and remainders. And as usual, you may want to pause the screen and try the problems on your own before looking at the explanations. Next, properties of zero. If 2x is equal to x, for what value of x could this be true? Well, how can twice a number be equal to the number? Well, 0 is something they often test. So, and if you did a little algebra, you would be saying, divide both sides by 2, how can x be a half of x? Well, if both are 0. Likewise, if 2x is equal to y, for what value of x is x equal to y? So again, divide by 2, x is equal to y over 2. How can that be true? Only if both are equal to 0. Next problem. If a times b times c is equal to 1, and b times c times d is equal to 1, and c times d times e is equal to 0, what must be true? Okay, so remember, must means always. If we can find an exception, it's not true. Must a be greater than 1? Well, a times b times c is equal to 1, but do they all have to be 1? No. A could be 10, b could be 1/2, and c could be 1/5. Or a could be 1/2, and b could be 10. So you really can't tell what the values of these could be. Or one could be two of these could be negative. So it's not that a must be greater than 1. And you could go down through all these others. B doesn't necessarily have to be a particular value to make these true. And same with the B, C, D equal to 1. So C doesn't have to be equal to 1. D doesn't have to be less than 1. D could be 10. C could be 1/2. B could be 1/5. Okay, but must E be equal to 0? Well, so this is testing the rule that if a times b is equal to 0, it's because a is equal to 0 or b is equal to 0. Or if a times b times c is equal to 0, it's because a is 0, b is equal to 0, or c is equal to 0. So when you see 0, you may be thinking of that rule. So one of these has to be making this 0. So could it be C? Well, no, because otherwise this would be equal to 0. Likewise, it can't be D, because otherwise this would be equal to 0. So the only thing making this equal to 0 has to be E. Next, remainder problems. For example, if 4 consecutive integers are divided by 4, what are the possible remainders? So let's be concrete. So let's say, 20, 21, 22, and 23. Okay, so 4 gives 0 remainder. 20. So remainder problems, you have to do the long division. You can't use the calculator because it's not decimal division. So, and okay, so these are possible remainders, but we don't see it in there. So But it doesn't have to start with 20. It could start with 21, 22, 23, 24. So let's say, well, if we went 4 into 24, 4 sixes are 24, the remainder is 0. So you see the pattern 0, 1, 2, 3, then it'll be 0, 1, 2, 3, or it could be 2, 3, 0, 1, which is E. And what concept are they testing here? If you're dividing by 4, you'll never have a remainder of 4, which eliminates those. For example, if you're dividing any number by, say, 7, the remainder will never be 7, because you wouldn't do something like this. You'd do it 4 times. So the remainders dividing by 7 have to be 0 to 6. Dividing by 13, the remainders have to be 0 to 12, etc. Next problem. When the integer n is divided by 11, the remainder is 9. So another remainder problem. And what is the remainder when n plus 3 is divided by 11? Okay, so what would be an example of a number that's divisible by 11 and will give a remainder of 9? Well, let's start with a guess. Let's say if you chose, let's say, 15, you have a remainder of 4. So how do we get a remainder of 9? Well, we want to go 5 up here. So how about going 5 up here? 1 is 11. We get 9 remainder. So this is a number that qualifies to be an n. Okay, so n equals to 20. What is the remainder with n plus 3? Well, that's 23 is divided by 11. Well, 11 goes twice, 22, so it gives a remainder of 1. Okay, and one way to think about it algebraically is a division problem is you're looking for a multiplier. So you're saying 11 times some number plus the remainder is equal to n. So a division problem is when you're looking for one of the multipliers. So you have 11k plus 9 is equal to n. So what is the remainder when n plus 3? So algebraically you would add 3 to both sides, and you get a 12 here. So 11 would go into it that times, but it would go into it one more time, and then you would have a remainder here of 1. Because that would go into it 11 plus 1 time. Okay, enough on that. But again, whenever you can, be concrete, but get numbers that meet their conditions. Okay, when 19 is divided by n, the remainder is 3. They want to know for how many values of n is this true. Okay, so what would be a good place to start? Well, how about 1? 1 into 19, remainder of 0. 2 into 19 goes 9 times 1 remainder. I want a remainder of 3, so we'll go up 2 here. Wait, no, because Well, the remainder of 3, we want this to be a 16. Okay, so but 3 and a 19, 3 6s are 18. That doesn't work. Let's see, 4. Well, 4 will get us to 16. 4 4s are 16. We have a 3 remainder. So you could check 5, which would go into it, let's see, 3 times, but with a 4 remainder. But the key here, and the time saver, is that you're looking for a 16 here. So another way to get a 16 there is by 8. And the last way to get a 16 is with 1. So these are the types of problems where they separate the low scores from the high scores. If you see the concept they're testing or the pattern, you save some time and have more time on harder questions. This video was brought to you by MathGalaxy.com. And remember, there's no substitute for tackling problems on your own. And these problems on the 10 practice tests in the SAT Blue Book are all related to number properties. For example, on practice test 1, section 3, problem 11, section 7, problem 10. And if you need further review for high school math topics, you can visit us at MathGalaxy.com. Thank you for listening.